Hey everybody. So it looks like it is time for us to finally start our images and graphics module or unit for your first website. And during this unit, we are going to be covering image optimization strategies, file types that work on the web for visual assets, and how to prepare your images for the web using a program like Photoshop, and also other things like how to write appropriate alternative text to make your images and graphics accessible. So I'm going to go ahead and go over the PowerPoint that we would normally do in class at this time so that we can get started with that information. So image optimization, how to prepare images and graphics for the web. It may or may not be news to you that we cannot take our images and graphics straight out of either the programs that we use to create them, like Photoshop or Illustrator, or GIMP or any of these other applications, Procreate, etc., and put them directly into our websites. But we instead need to take them through a process where we optimize them to bring down their overall dimensions, like the total number of pixels that they take up in terms of width and height. And the other thing that we need to do is we need to take them down in terms of total file load. So like, how heavy is that file? How much does it weigh in terms of kilobytes, megabytes, gigabytes, etc.? And then in addition to that, we need to conform it into a file type that a browser can actually read and then present on the screen. So those are some of the key topics that we're going to be discussing to get us started. So I like to start this lecture with a reminder of the workflow that you are going to use to take your images from their sort of found or original state and then process them so that you can use them in your website. So we're going to talk about it first, being that we begin with what is called our source images. So the source images are images that might be unedited images. They might have come from your camera or from your client, or they were scanned, or they were a stock asset. And they are the original that we really want to preserve in its original state, and we will make copies of that file, and then we will use the copies of that file to prepare to go actually onto the web. So we always want to keep an untouched version of our visual assets so that we, if something happens to one of the ones that we did optimize or that we did edit, we can always go back to the original and start over again. So files like this, we would want to keep inside of our source folder. Remember that inside of our master project folder, we have a source folder and we have a root folder. And the root folder is all the files that actually do go online, like index.html and styles.css and all the other HTML files and prepared assets. And then we have our source folder, which is a part of our project, but it's all of the things that have not been prepared or are not intended to go online in the form that they exist when they're in the sources folder. So that's the same thing with our images, with our graphics, with our logos, all of that. They start somewhere else as an original, get stored in the source, then we take it through the process, and then it ends up in the root folder so that we can actually use it in our website. So those originals that we would have, which would be something like, so those originals, which would be something like perhaps a TIFF file or a JPEG or a PDF or an EPS or any of those other file types, could also be something that you created using Photoshop or Illustrator if you were creating something from scratch. But those are the files that are going to stay inside of your source folder. Then, when you are ready to start working on your image for your website, you're going to take your source folder or your source file and you are going to turn it into what we will consider the master working file. So this is going to be like the file that you are editing, enhancing, cropping, adding filter effects to, adding a color fill over so that it will work better with the aesthetic of your website. So this is a file that we are making modifications to. Maybe we're taking it from, it was a horizontal orientation and we want to crop it down to a square or even a circle. Maybe it's something that we wanted to put a different color effect over so that it would better integrate with the colors on our website. Any of those are actually going to be our master working files, and we're going to also store those in the source, because even though we're preparing them to eventually go online, they're not currently prepared to go online. So this is the one where we want to keep all of our layers, we want to have the full resolution, we want to keep everything in that sort of edited but full quality. And then what we'll do is we will take that file and we will move it into a file type and an optimization strategy that is going to work best for the web. So we're going to take those files like our Photoshop, Illustrator, InDesign file that we have enhanced, and then when we save it out, we're going to save it out through a process that is currently still available in Photoshop and Illustrator called Save for Web. And during the Save for Web process, we are going to convert our files into either a GIF or a GIF, a PNG or PNG, and a JPEG file. Those are the three file types that we can take online currently for our images and graphics. Those files, when we save them out, optimized for the web and saved in one of those file types, those will be the files that go into the root folder, which means that they are actually going to go online in our website. So let's take a look at some examples of JPEG, GIF, or GIF, and PNG files and how you might be able to recognize them. So this is a really important part of this unit, is that you understand the difference between the three different file types and when you use which file type for which type of asset. This is something that I am going to be evaluating on your website, and so it's something that I do need you to pay attention to. Let's go ahead and start with JPEG. So JPEG is, let's go ahead and start with JPEG. So JPEG is a file type that many of you are already very familiar with, and we're going to talk about some of the things that JPEG does well. So JPEG does really strong support for what we call continuous tone images. And I want you to take a look at the photograph in here and see how everything that we see inside of this image is sort of like in a gradient, right? From like a slightly darker gray, we go to a lighter gray, and then we sort of alternate in here to give the appearance of the wrinkles on the face. Or we have a coat on, but the coat, and we will interpret it as being a dark coat, but we can see it in here that it's actually moving from light areas of the coat where there would have been a highlight coming in to dark areas on the coat where there would have been shadows in the image. But in all, they're not solid blocks of color. It's actually continuous tone. Continuous tone is essentially what we see when we look around us. That's what reality is. So you can see the shadows, or that there's a highlight on this side of my face because the light source is over here, and that I might have some shadows on this side. But my skin is constantly moving in gradients, and that is continuous tone. So that is one of the key features of a visual that we would tell us that we want to save it as a JPEG. Let's look at a couple of others. So the other thing is that the source might be photographically based, meaning it looks like it was taken from life. It was taken with a camera lens. Other things that fall into continuous tone and may be best suited or saved out as a JPEG would be images or graphics that have a very heavy use of gradients, glows, and drop shadows, because we need to be able to transition from one value to another, from one color to another, and for that, JPEG really makes the most sense. So let's talk about some of the cons. So in terms of cons, things that JPEG does not do well. JPEG does not have any support for transparency. Where you can see through an image is where we need to have support for transparency. JPEG does not support any transparency. So the images are always going to be solid, and if there's something behind them, that thing is not going to be visible. Another thing that JPEG is not good at, it's not good at representing large blocks of solid color, like what you might be seeing here in the example of a GIF, where we have large blocks of a single color, and we don't want it to look textured, we don't want it to look like a gradient at all. JPEG is really not very good because of the way that it compresses for representing images or graphics with large blocks of solid color. The other thing that you should know about a JPEG is that a JPEG is a lossy file type. And what that essentially means is that if you open up a JPEG and you make any changes to it and you save that JPEG, when you save, you throw away or lose a little bit of data, thereby making this a lossy file type, which means that we lose data every time we save a JPEG. So JPEGs are not good files for you to open, edit, save, close, open, edit, save, close. You really need to go back to the workflow, right, where we start off with a JPEG, perhaps, take it into a program where we want to edit it, save it out as a lossless, something like a TIFF or a PSD or an Illustrator file or a PDF, something like that, and then use that as the file that you will make edits to, and then move it forward into saving it back out, perhaps as a JPEG at the end. But we don't want to make changes and save over and over on a JPEG file, because every time it throws data away, then the next time it opens up, it has less of the original data, and more data was data that was made up. Okay, so let's go ahead and move on to GIF or GIF. I know that most of you probably call it a GIF, and it seems funny that I would call it a GIF, but the person who actually developed the file type had a little jingle for it, and he said, "Choosy designers choose GIF," and that is how he described and pronounced the file type. So I will always call it a GIF, but you may call it a GIF because that is also okay. Okay, so let's talk a little bit about what does a GIF do well. So a GIF does a really good job of saving images or graphics with large blocks of solid color, much like the one that we see up here. So it also does a really good job of saving out animated GIFs, which is a file type that, well, GIF is a file type that supports multiple frames inside of a single file, and it will play those frames back in succession and loop them. So that's where we get the animated GIF. So those are mostly the two main things that GIF are best suited for. A lot of logos, a lot of graphic work that comes out of a program like Illustrator might be made up of large blocks of solid color, and therefore may be best optimized out as a GIF. Some of the things that GIF does not do well. So just like working with a JPEG, it has poor support for transparency. Yes, it can actually produce transparent areas, but there are so many limitations on how it does that it's just not recommended if you're trying to get transparency in an image or a graphic file. We'll talk about that in just a moment. It's also not good for continuous tone, so that real life rendering with shadows, highlights, gradients, glows, those really are not best for the GIF output because, again, it's better at dealing with solid blocks of color, not so good at having enough color variation to be able to represent continuous tone images. And that is because GIF only has 256 unique colors that can be represented in each file. Now, the 256 colors are specific for each image that it is trying to reproduce. So, for example, if I was trying to represent, let's say, this box right here in a GIF. And you can see in here that it only has, you know, reds and cream colors in here. It could actually represent that really well because it only takes a few different colors to recreate this image, even if we have a highlight. So even if we have some continuous tone in here, because the color palette is so narrow, in scope, it's going to be able to do a decent job of pulling 256 different colors of red to be able to represent all the different values and even the gradients in here. But if I were to get an image that was varied, let's see if I can find something right now. Let's say something like this, where I have many different colors and then many different sort of values or variations on each one of those colors. It's going to be really hard for the GIF file format to pull out 256 unique colors and then to be able to only need those 256 colors or only have access to 256 colors to then try to represent this entire image. So that's a little bit of a stretch for a GIF file format. And so that would probably not be the best file format for an image like that because it needs continuous tone, which is lots of color, lots of variation as we move and transition from even just the darker and the lighter areas within a single hue. And then the last one that we have in here is ping. So ping is essentially the answer to all of our prayers. It is the Swiss Army knife of graphics file formats. It's absolutely amazing. So what's the problem, right? Well, let's talk a little bit about what ping does really well, and then we're going to talk about why you don't get to just use it indiscriminately yet. So ping has support for something we call alpha transparency, which means that every single pixel that makes up this image can be any variation on fully solid all the way to fully transparent, meaning like you can see through it. And it can be any amount of transparency between 0 and 100%. And any color can be. Where GIF, you can identify a single pixel color and turn it either to be visible or invisible, so transparent. On ping, it can be each individual pixel that makes up your images, and it's all these little squares in rows and columns, and every one of those can be a different color. Well, in a ping, every one of them can also be a variable amount of transparency, so it can be partially see-through, mostly see-through, just a teeny bit see-through, just a teeny bit more see-through, and that's each individual little tiny pixel has that much of a variation that it is allowed to adopt. So that's what we call alpha transparency. And it's why, even though inside of this there is actually a rectangular image file in here, it is transparent all the way up to the edge of this leaf. And so instead of it looking like a rectangle like the other two image file formats or graphic file formats that we're seeing in here, we don't actually see that background because it is transparent. We're seeing through to the background of the slide. So that's what we love about ping, is that it has this alpha transparency. However, in addition to that, it also supports everything that JPEG does, so continuous tone images, lots of color, gradients, drop shadows, and glows, and then it does an equally excellent job of dealing with images or graphics with large blocks of solid color. So again, I told you it's a Swiss Army knife. It's like our dream. So what's the problem? Well, we don't really get to optimize it, meaning we can't like squeeze file size out of it to make it smaller and more transportable, which is really something that we need on the web. So it makes really massive files. So the files, we'll see a comparison in an upcoming slide, but it makes just unbelievably huge file sizes compared to a JPEG or a GIF version of the same file. So it really is something that we can't afford to use indiscriminately, okay? So primarily for our class, I would like you to treat PNG as being the file type that you use only if you need to have transparency in an image or a graphic. Or if there was a very unique case where JPEG or GIF was going to give you a larger file size than a PNG, which I will say basically never happens. So there you go, JPEG, GIF, and PNG. Okay, so we are looking specifically at JPEG right now, and this slide is meant to show you some comparisons of a photographically based image that has been optimized out as a GIF, as a JPEG, and also as a PNG file, as a way for us to kind of also notice that when we optimize our files out in the most appropriate file type, we also usually get the smallest file size. So let's take a look in here. This is a photographically based image taken with a camera, saved out as a GIF file. You can see that it's 52 kilobytes, which means that it is a pretty small file, since there are essentially 1,000 bytes in 1 kilobyte, and 1,000 kilobytes in 1 megabyte, and 1,000 megabytes in 1 gigabyte, and 1,000 gigabytes in 1 terabyte. So since we're really used to seeing file sizes in the megabyte range, seeing something that is 52 kilobytes may not seem very large to you. However, it is our responsibility to try to always get our file sizes down to the lowest possible file size while not sacrificing quality of our visual assets. So in here, what we're seeing is that this has been sized down to 52 kilobytes, which is a reasonable file size. It's a good file size. It's something that we would like to aim for. One of the things that you may or may not be able to see in here is that in areas where there should be a transition of colors, so look at the JPEG version of it where you can see the transition of the rouge on the cheeks, and it's a very smooth transition and it retains all of the color. When you see that optimized out as a GIF file, you lose that smoothness of continuous tone and will sometimes lose complete colors altogether, which you really are actually seeing in here because this has sort of been grayed out a little bit, so it's not nearly as saturated and vibrant as it is as a JPEG. So in some of the other areas where there are a lot of transitions, you're just going to see that the way GIF renders when it is compressed is you're going to see it in little dots that almost looks like stipling, which is like a drawing technique. So it's not ideal, and I can see it quite a bit across the bridge of the nose and in the cheeks, and especially in the areas of color in here. Now, this is an image that has been optimized out as a JPEG, which is the correct file type for this particular file. It has been saved out as 56 kilobytes, so that was basically the smallest file size I could get while not sacrificing image quality. The JPEG is clean and it has a smallish file size, and in comparison to the GIF that is an equal-ish file size, it represents much more true to the way that the original would have looked. So I can see the smooth, continuous tone, not a lot of large blocks of solid color, so it's doing a really good job. Now, over on the right-hand side, what we see is we have saved this file out as a PNG, and it is 205 kilobytes, which is roughly, 4 of these files together, equaling about 1 of them when they're exported as a PNG. So remember when I said PNG is excellent, does a really good job at everything, but it comes at a sacrifice of file size. So because we cannot compress it down or sacrifice quality or change a quality slider, when we work with a PNG, we just sort of get what it gives us. So when I look at this image and I look at this image, there's no noticeable quality difference in the output, but the file size tells me that I really should not be using a PNG for this. There's no transparency, and the JPEG does an equivalent, excellent job at representing the image, but at 1/4 the file size. Okay, let's go ahead and take a look at a GIF in here. So it says a GIF for animations. We'll play the little animation in here. Since we actually get to see it, none of my other students, when I play this in the classroom, ever get to see that because the animation, for some reason, does not translate over. So there's my little animated GIF for you that we do in one of my other classes. And solid color graphics. So you can see in here that we have kind of a comparison of a couple of different things that GIF does really well. So very simplified, solid color graphics in here, and also animations. And then let's go ahead and take a look at our PNG specific slide. So remember that PNG is really the file type that we are going to reserve for images or graphics that require transparency in them. So this is another comparison. So what we're seeing right here is here's a GIF with a very small file size. It does have transparency in the GIF, which is why we don't see the square behind it. Essentially what happened is as soon as the edge of this drop shadow went to full transparency, that was the ring that was created in the GIF to create the transparent region. So everything outside of the drop shadow, and the drop shadow you can see, it's hard to tell, but you can tell that the drop shadow is actually kind of in its gradient going from opaque or solid into, sort of transparent regions, and only one pixel is allowed to go to full opaque or full transparency, and that's why we have this really weird transparent region, which is everything outside of that last indicated pixel. Next to it, we have a low quality GIF meant to show you kind of what happens with that compression artifacts inside of a GIF, where we see all the little dotting in there because it cannot, in 256 colors, it cannot translate that smoothness of the gradient. However, this was a file that was being represented by far less than 256 colors. This one had 256 colors in it. This one might be being represented by something like 16 colors. And so to make it a smaller file, we reduced the number of colors that the GIF was using from 256 to maybe something like 16. So it brought the file size down really low, but you can see at a sacrifice for quality. Then we have the same image represented as a JPEG, and again there's no transparency, which is why we see the white background behind it. And then we see the file being translated as a PNG, which is the correct or optimal file type for this particular file. And it's only 15 kilobytes, which is not bad, and the transparency is lovely. So you would never even know that there is actually a rectangular sort of format around the outside of this. So I hope that those help give a good explanation and some examples of when, where, and why we want to use JPEG, GIF, or PNG for our files. Part of the conversation that we also need to have right now is in relationship to resolution for your web assets. There are a few things that I want to make sure that we talk about in this conversation. One of them is going to be what I refer to as our mantra for image optimization, and this should be driving your decisions as you go forward and optimize your assets for your own websites and for anybody else's web projects that you are engaged in. So when we are preparing our images and graphics for the web, not only do we have to take into consideration the proper file type, JPEG, GIF, PNG, and also SVG, which we're not talking about it now, but we also need to be thinking about the proper dimensions, meaning how many pixels across and how many pixels down. such as 820 pixels across by 300 pixels high, as well as the total file weight or file size in terms of kilobytes, megabytes, never gigabytes. So when we're thinking about resolution on the web, it really means a couple of different things to us. So let's go ahead and start from the top bullet in here. In terms of the file weight, our job when we are processing these images is to keep the file size as low as possible using our mantra that we want the best quality image at the lowest possible file size. So our job is to optimize and shave off file size, which you'll see when I do a demonstration on the process. But the point is that we want to reduce quality in an effort to reduce file size, but never by over optimizing so that our images or our assets are falling apart or losing quality. So we're trying to work on this balancing act of getting our file size down while still retaining a high quality visual asset. The other thing is about thinking about the total dimensions of the images or assets that we're working with. Because we are currently working with a fixed width layout, meaning that we are not doing responsive designs where the images get bigger on a larger screen and then smaller on a smaller screen, then that actually simplifies things for us at this point. And what we are looking for instead is the total number of pixels across and down, so that our images and graphics fit into the position and fit into the space that we have allocated for them in our design. This is why we've been using placeholder images. So up until now, you should not have any actual images or graphics in your website. You should only have that placeholder image link that we put in Squint so that you can test different dimensions, right? So 960 by 140, or maybe it's 80 by 80 for a logo, or maybe it's 220 by 140 for a small sort of banner elsewhere inside of your site. So right now what we're thinking about is how much total space do we need our asset to occupy in our layout? And that's why we're using placeholder images. So that is also part of our conversation about resolution. And then the last thing that you need to know is that when you get further along in this field, if you choose to go further, or if you ever do design for websites, so where you are actually optimizing and creating web assets, but not necessarily doing the coding, then you will eventually need to concern yourself with the fact that we have many different types or places where we need to be thinking about resolution. So for instance, on like a small phone where the total number of pixels across and down is going to vary greatly from that of my laptop or a larger desktop or a tablet. When it comes to that time in your life, you will be asked to take the next step in understanding resolution and how to size image assets for the web. But at this point, we don't have to worry about that because we are starting at the beginning. Okay. So the next part of our conversation in this slide presentation is just to give some clarification on the fact that we do actually have more than one way to add a visual asset such as an image or a graphic into our website. What we have been working with so far is foreground images, in which case we use the IMG element. So that's the way that we've been adding images into our website so far, by actually adding in the code for the IMG and then putting in a source and then loading the file in that way. However, as you get more sophisticated, you are going to want to also be able to bring images and graphics in through CSS. And in that case, we refer to them as being in the background. Let's go ahead and talk a little bit more about that. So We can use them in the foreground as content, as the image element, or we can apply them purely as decoration in the background using CSS. So it's really the same distinction that we've had all along from HTML as content and decoration is CSS. And so our two different languages are responsible for serving up our different elements of our design. So either the content that we are styling with CSS or the decoration that's coming purely from CSS. So when you are making this consideration, I want you to take these matters into account. So images in the foreground are considered content, and they should be used in a meaningful manner as a way to add information to your site. So these would include visual graphs, images with words on them, instructive images, like they're saying something like, stir the broth or stir the liquid or whatever, and they actually are showing you an image that is diagramming that or modeling that. Samples of your artwork, covers of a book, etc. So if you could ask yourself, if this image disappeared, it would hamper the understanding of the content on my site, then that is a clear indication to you that that image should be added to your website using HTML and the image element. Okay, so when we move forward and we learn more about background images, then I need you to also take into consideration what is the best use or what is the reason for choosing an image to come in as a background or through CSS. So my note says, images in the background are considered decorative and should not carry any meaning or provide a function or have any words in them. Consider what the impact would be if the asset disappeared. If there wouldn't be any impact if the image or the asset disappeared, then it's okay to use the asset in the background through CSS. This would work if it was an image that we didn't need to click on, if it wasn't being used as a link, if it wasn't representative of any content, if it was there just to sort of create graphic appeal or to apply a texture or to apply a gradient, then those are purely decorative, and if they were missing, nothing would really change about the transmission of information, then that really is a good case for applying the image through CSS. Now, we are not necessarily doing that in this particular website, but that is something that we would learn about in our second personal website. So let's continue to talk about our use of images with the image element. So image is the HTML element for displaying image content. And we also have another element that's very closely related. It's called picture. And so instead of using IMG, you would put in picture. And we use that more frequently when working with responsive design and websites. Image has numerous attributes such as width and height, source, which is like where does the image live in your folder or online that you wish to present. Alt, which is our accessible attribute and helps us share the meaning of the image with those people who are not sighted or have low vision. We also have a couple of others. One of them is called title. So you know how sometimes you get like a little tiny tooltip that pops up when you hover over something? That whatever is in that tooltip, whatever the words are that show up, that would be the content that you would put in the title attribute. And then we also have another one called the long description attribute, which allows you to link to another document that's going to explain the graph or the data or the visual or the image because it requires a longer description. So there are many other attributes that you can also apply to IDs. So images, though, must always include source. Where is the image? Where does the file exist so that it can be shown? And also alt. So up until now, we have been seeing little yellow warnings in our HTML code when we don't apply alt properly to our image elements. And once we apply the alt attribute, then that soft warning is going to go away because it is a requirement for the image elements. So again, for the first site, we're really thinking about the proper use of HTML and CSS, info architecture, semantics, syntax, and following the full process. When we get into our last website for this class, there'll be more information on how to apply background images to add a little bit more complexity to the visual design. But for now, we are going to continue to use foreground images for the most part in this unit.